Question 5, June 2019. The question states that an aircraft gas turbine engine operates on an ideal Brayton cycle with a pressure ratio of 8. The gas temperature at the compressor and at the turbine inlets are 27 degrees Celsius and 1000 degrees Celsius. Given the isentropic efficiencies for both compressor and turbine equal to 90%. Assume that the working fluid to be air throughout the cycle. Sketch the cycle on a TS diagram and determine the compressor and turbine actual exit temperature in Kelvin, the back work ratio, the thermal efficiency of the cycle in percentage, and the change of the engine's thermal efficiency in percentage if a regenerator with 80% effectiveness is added to the system, and briefly explain the changes. Given in the question is the constant specific heat Cp, Cv, specific gas constant R, and specific heat ratio gamma. Given to us from the question is the pressure ratio Rp equal to 8. We know that this pressure ratio is equal to P2 over P1 and P2 is equal to P3. Also, P1 equal to P4. Next will be the compressor inlet temperature. With respect to the TS diagram that has been drawn, this is referring to T1, and then the turbine inlet temperature equal to 1000 degrees Celsius. This is referring to the temperature for state 3 with respect to the TS diagram that has been drawn. Also given to us is the isentropic efficiency for both compressor and turbine, which is equal to 90%. Now we are going to determine the temperatures for each state for the cycle. For state 1, the temperature is given from this question, which is equal to 27 degrees Celsius, and please do not forget to convert this into unit Kelvin. For state 2, we know that the pressure for state 2 is equal with the pressure for state 3. Next, from the isentropic relationship for process 1 to 2, we can determine the temperature for the state T2S. Once we obtain the temperature T2S, next we can determine the actual temperature for the state 2 by using the isentropic efficiency for the compressor. For state 3, the temperature has been given by this question, which is equal to 1000 degrees Celsius. And do not forget also to convert this into unit Kelvin. For state 4, we are going to determine the temperature for state T4S by using the isentropic relation for the process 3 to 4, which is across our turbine. Again, once we obtain the temperature for state 4S, next we can find the actual temperature for state 4 by using the isentropic efficiency for the turbine. This will be the answer for item A requested by this question. Item B requires us to determine the backwork ratio, which can be determined by using the formula of work input divided with the work output. With respect to the steady flow energy equation and the method to determine the properties for ideal gases, we can get this expression for the backwork ratio. Next, you will need to substitute all the necessary values and calculate. Thus, you will get the value for the backward ratio is equal to 0.5 to 7. Item C requires us to determine the thermal efficiency for the Brayton cycle. The thermal efficiency can be determined by using the formula of desired output divided with required input, and for this Brayton cycle, the desired output will be the net work output and the required input will be the heat transfer in. Since this question requires us to determine the thermal efficiency in terms of percentage, thus please times the thermal efficiency with 100%. With respect to the steady flow energy equation and the method to determine the properties for the ideal gases, the net work output and the heat transfer in is given by this expression. Once we substitute and calculate, we're going to get the value for the net work output and the heat transfer in. This value can be substituted into this expression. Thus, we can obtain the value for the thermal efficiency for the Brayton cycle. For item D, they require us to determine the thermal efficiency of the engines if a regenerator with 80% effectiveness is added to the system. And we also required to briefly explain about the changes. For this, we are going to compare between the new thermal efficiency with a regenerator with the thermal efficiency that we have calculated in item C. If we draw the Brayton cycle with regeneration, the TS diagram will look like this. From the formula of the effectiveness of the regenerator, we can now determine the temperature for state 5. Since we are going to determine the new thermal efficiency for the Brayton cycle with regeneration, thus we need to obtain the value for the new heat transfer in, which can be given by this expression with respect to the steady flow energy equation SFEE and the method to determine the properties for the ideal gases. Once we obtain the value for the new heat transfer in, we can now determine the new thermal efficiency. Next, we are going to get the change between the thermal efficiencies that we obtain from item C and item D. Next, you are required to write a statement to explain about these changes of the thermal efficiencies. For example, you may write, this improvement is because of heating energy, heat transfer in requirement is reduced as a result of installing a regenerator.